Well, hi, good morning, and thank you so much for joining me in my shop and keeping me company here. Today is August 23rd, kind of a gray day here. I think some rain may be coming later. So today I'm probably not going to work directly on the radio. What I want to do is I want to explore some IF transformers. That I've installed a new one in here. It's not working out. And I have a number of observations, all add up to big question marks about a lot of things. So just to go over the background a little bit, so I got this radio. I checked the IF tuning. It was a little bit off. It was way off, in fact. So I wanted to move the slug in the IF transformer. Here it is here. And one of the slugs just got stuck to the point where I could not move it anymore. And I discovered the other slug is a aluminum metal slug. Kind of odd. I think it's aluminum. I don't know what metal it is. So I removed this because I couldn't tune it, because I couldn't move the slugs in it properly, and replaced it with an alternative, 3 of which I have in this bag. So the bag says Admiral Genuine Parts, and there were 3 of these in here. Obviously this is really meant for an Admiral radio, but does it really matter? This is the information sheet that comes with it. It says right on it, 455. Oh. Uh-oh. I just noticed something here. Yeah, I saw this 455. What I never noticed was there's 2 boxes here. There's another one, 262. Oh, that might explain everything. That might explain everything right there. So this is a 1655.3. 1655.3 is the 260. Oh my gosh, is that true of the one I have in there? No, this is from the. Don't get too excited now, John. I think I just stumbled on something I hadn't realized at all. Let me just look and see. And what I'm doing is I'm trying to read the writing on the can that I installed in there. Oh my gosh, I can't believe this is this situation, is it? It's a 1655.3. Oh my gosh, it's a 262 kilocycle. Huh. Oh man. Well, this well, let me tell you. Outside of the radio, in my private time, I took one of these, which is identical to the one I put in there, still not knowing it's a 262 kilocycle IF can, and I put my VNA onto it, and you know what? It was showing up at like 2 something. Oh, what's going on? So I figured my test was invalid. Something was wrong with how I was doing it. Here it is here. I still have it connected to the VNA. It's right here. Oh, this is a 1655.3. Yeah, they're all 3 of them are the same. Oh my gosh. Paradigm thinking, right? I'm just convinced it's a 455 transformer. Okay, well, that really does highlight a lot. I thought it was fantastic. I had these IF cans. Now, we're going to have to do another one. So I have some more in here, but goodness knows if these could ever work. This out of another radio, I'm pretty sure. Got a number on it. It's got 6 leads. That's not too good a sign. This one I removed from a radio myself, and see it says SMD. That's for silver mica disease. So this would probably work in there, except the oh, it's very strange looking, very different looking. Where's the coils? The capacitors are molded, are fitted, built right into these things, right in the plastic base. Well, so now I don't seem to have one, do I? What about this one? Oh, 60. It's one of these again. Jim, don't get mixed up. You have one more here. So this has got a number on it again. course, they won't write right on it, would they? Well, we could VNA this thing and find out what it is. But, I mean, it's just, I have no idea where this came from. I have it. I don't know how I got it. Well, okay, another alternative is to restore this one. You know, I have some little tiny ones, but I can't imagine you could ever use something like that in a radio like this. I don't think it could withstand the voltages. Not that they're that high in this radio, they're not that high. So the reason this came out was because I couldn't move the slug in it. Well, one thing's for sure, the IF that's in there has to come out. It's of no use. And can I steal one from another radio entirely? Just take it out of another radio and stick it into this one? That's kind of what I was doing with the with this. Oh my gosh, I can't believe it. Well, okay, the good thing is I now know what's going on. Or at least I think I know what's going on, which is a good feeling. Good false feeling. I got to make a decision here about this. How could we, and there's only one slug in it now. I'm pretty sure there's only one slug in it. The other one, where'd the other one go? I don't remember what I did with it. I think it's time for some coffee. Did I give a warning at the start of this video? I meant to give a warning that, first of all, be assured there's no AI involved in the production of this video unless you hear me talking to an AI system. You know fully well. So I'm a human being. AI is not here. The question is there any intelligence here at all? That's really the question. I think I'm going to go and get my coffee machine going. Hunting around for some old radios with IF transformers that I might be able to steal. And this is my play around chassis here that I do stupid experiments with. And it has an IF transformer sitting there. It's connected to nothing. Why don't we put the VNA on it and just see what happens to it. It's really not the right size, like physically not the right size, but and I don't know for sure that there's capacitors built into this. Got no idea. And I don't even know which wires to hook up. So this is the S11. It's that yellow line running across the top, and it's running from 300 to 600 kilohertz, and it's just showing no response at all. And if you think I know what I'm doing, no response there at all. You know, it could be the capacitors are not built into this one. I don't know. I would like one of these to show up with a nice curve. Well, it's definitely responding. Okay. So I think in these older ones, you would tend to have discrete capacitors in the circuit itself. I can get this right out of here, I think. Maybe not. Maybe yes. Maybe yes. Not sure what we'll do with it, but we want to know if there's capacitors in here. Interesting question. What is this? I suspect this is a capacitor of a structure they've built capacitors with, but I don't know. just be something to I don't know, to steady this up. Well, I can see the where the wires are going now. So the upper coil is attached here and attached here. Big slug inside there. Nothing showing up here. Oh, maybe this thing resonates at some other stupid frequency. There's radios with IFs as low as 180 kilohertz. Let's go lower on this, just in case. I'll change the start to 100 kilohertz. No, there's still nothing showing up. And I may not be using this right. I have limited experience with it. Okay. There's still no evidence of intelligence in this shop. The top of these is shaped so it can catch the top of this piece and center it up here. That's the idea. Give it some structure at the top. Not working out. Okay, I'm going to try something else here. Okay, let's have a look at what I've brought in here. So this is a radio I have. I do not have any tubes for it. No intention of ever fixing it up. And bottom plate. Look at this. There's too many of them. Interesting numbers on them. This receiver, does it receive FM? So this is, yeah, this is FM, and this is AM. This is AM FM tuner. So a good number of these are potentially for the FM circuit, and they're going to resonate at probably 10.7 megahertz. And then some of these ones down here are probably the FM ones. These are probably the AM ones. These two anyway. You can't be sure that this cable cut right off here. Who did that? There's some big thing missing here. This must be a big magic eye or something. Going in here. I'm on the lookout for an output transformer. There's one here. Look at this. That's the tuning capacitor inside there. This is quite a hefty radio. I've never really looked at it very closely. Test jack. Antenna connections, FM, AM. Nothing special. Okay, let's look under here. We'll look at the bottom of those. So if I think I mentioned on the last video, I probably won't be posting videos for about a week while I am vacating with my wife, but we're doing a staycation. We're doing some short trips. We'll go down to Toronto a couple times. We're going to go to the Toronto Zoo and probably to this gigantic amusement park called Wonderland. I think it's still called Wonderland, Canada's Wonderland. Maybe it has a different name now. And a few other things. So consequently I won't be posting. Electrohome. Dominion Electrohome Industries Kitchener. Is that a big output transformer? What is that? That might be a big output transformer. I might be able to use that in another project. Lots of parts in here. So the cans of interest would be these two first off. And is there anything obvious about this? No, not really. We have a tube here. Did they label these tubes at all? So it's, they didn't label what it does, but what it is. It's a 6BA6. So these are typically, these are commonly IF amplifier tubes. This looks like the radio front end here. And I don't know. Are these going to be 455 guys? They're about the right size physically to go back in that other radio. Why don't I nip off? See, this one has 4 leads to it. I'm going to nip everything clear there, and we're going to try to test it. Maybe I'll even get it out of the radio at this point too. Nip away. Same kind of side clip sort of arrangement here. Is this the one? No. Which one did I just clip away? This one up here. Who's hanging on? Resistor I left. Green dot. Can't tell from these numbers what frequency it might be. Another number there, P2857. Lots of numbers up here, but none of them appear to be indicating what the frequency is. Let's put it on the VNA and we'll see what happens here. So yeah, I can see the capacitor structure across here. So we're going to go here, go here. We got nothing. For a moment, just as I was connecting them, there's a nice dip right where you'd want it, but it didn't last. Is this a valid way of doing it? I'm not even sure. Some funny stuff going on here. Well, maybe using a VNA is just to do this. Man, I could easily be doing something wrong. Maybe I need a resistor in the circuit or something. And it's just a bunch of shaky nonsense on here when I don't know what to make of that. How are we going to do this? Well, I can sweep a signal into it and look at the signal coming out of it and see what that looks like. Why don't we try that? Again, is there any intelligence in this shop? So what I've done here is I've put the VNA through a calibration process, and I'm using this as the 50 ohm test amount, which I've just done. So it has been calibrated, open, short, and 50 ohms. And we're going to try it again. See if the calibration was really the. It's red here because I didn't do the through. Does it matter? I don't think so. Okay, put it back on. Green one. You can see the structure. Still get nothing. It's going from 100 to 600. It just shows nothing. I'm sure I've done this before and seen a very distinct dip. Not this time. Okay, thought I'd give that a try. Calibration, but didn't seem to help much. So I've tried a number of things with this first one to try to show its resonant point. 455, 10.7, anything at all. I can't get anything out of this. So I'm going to try another one. I'm going to take out, I'm going to try this one here. Nope, it's got too many leads. Nope, that's this one that has too many leads. This one has 4 leads. And we're going to take it out. Just cut the wires free and then test it inside here. So what I'm trying to do is teach myself how to perform a test that will allow me to work on the original IF transformer. So once I have a test that I think I can monitor what's going on with this, then I can start fooling around with this and trying to get it back into the radio. And alternatively, maybe in the process of doing this, I will find another suitable replacement. So that's the hope. Easy to do. Okay, that might be it there. There's a resistor there again. Looks like it has the very same numbers on it. Very same numbers. So I wouldn't expect any difference here. Let's try the VNA. Green dot, and I can see the structure, the capacitor structure. At least I think I can. Okay, so I'm showing you nothing. Seems to be heading down here, but this is very low. This is 100 kilohertz here at the bottom. So this isn't showing anything up. And I'm probably not using this correctly. It's probably what it is. But I also have my sweep generator going in the back here. This guy here. So I'm going to hook him up. And hook up my oscilloscope, which is also going. You can see it there. Nothing shows up. And this is going full tilt. I've got as much output out of the sweep as I can. Nothing showing up at all. Well, giving a little bit of RF there. Again, I'm probably not doing this correctly. Hooking up these leads, probably just disturbing the circuit inside. We're not getting anywhere here. So I've taken out another of these transformers, and I'm unable to get any kind of response in any way that indicates its resonant point. And again, I'm sure it's me not doing this the right way. So I'm going to open it up now and just prove to myself where there's capacitors in here, and it's a very different looking one, isn't it? it looks to me that the coil is up inside these things, and then you're sliding these up and down to affect their resonance. The coil would be inside there. Yep. This band coming around here, this is interesting. Sorry, my focus is back here. I gotta hold it maybe back here a little. That doesn't really help, does it? So looking in the base of it, well, you can see there's, what can you see? You can see this comes up into the structure, bends across it. I can see it, maybe you can see it too. Bends across it. And almost certainly, oh, there's a rivet in here. I think the rivet is not in any kind of contact with this metal piece coming across, and then I think there should be another metal piece coming, yeah, I can see it from here, coming across. So I have two metal pieces doing that, and that's a capacitor. And there they are. So they're definitely there. I mean, there's no question there's a capacitor in there. So definitely this is one circuit. Where are the wires? I guess they've really hidden the wires away. The wires that come up to the coils here. Well, I can see them winding down through here. Very, very, very thin. Okay, fine. So if I, for instance, do what I've done over and over, if I put the VNA on here, my somewhat calibrated VNA, maybe S11 is not going to do it. I'm going to try an S12 test on it. I don't have another lead handy. There's just no indication there at all. This has been a complete flop. I don't understand why exactly. I think I've been successful in doing these kinds of things before, especially the sweep. So this is the sweep output here. It almost looks like there's no capacitor here. There's one here. Ah, I think there's only one on one side. That makes sense. No, it doesn't make sense. You need a capacitor to resonate against. So maybe it's in the circuit here or something. Or I'm just wrong. I think I'm probably just wrong. Okay, one of these coils is getting an input. So there's the green dot right there. Okay, we got something happening on the scope. Whoop. We had something here. More like what I would expect. Okay, scope. Well, a bit of a distance for you to see it, but I'm going to just continue with this camera. When you look at the scope, I'm sorry, I'm going to have a lot of trouble getting a good image of this. This trace is widening out as you go this way, as if it's heading towards a resonance. Right now we're sweeping up to 546 kilohertz. So I can go way up from there. 3000 now. I can see there is some kind of resonance thing happening here. We're now sweeping up. Yeah, the frequency up here, the top frequency, you can definitely see it's curving back down. The top frequency here is 1800 kilohertz. I'm sorry, the top frequency is 3000 kilohertz. The bottom frequency is 1800. Let's lower the bottom here, way down. Oops, way down, way down. Like that, I can't. So there's some way I can't go low, way low, and way high at the same time with this guy. Well, now you can really see the shape. The resonant being out here. That's 60,000 miles from where I want it. That's very odd. Okay, so let me just grabbing it here. I'm going to turn the one of the slugs. Oh, look at that. Reach the end and turn the other slug. Well, it's got a nice resonance now. But what frequency is that? Or is this, you know, I've hooked up this equipment and it's just disturbed the resonant frequency and moved it way off to there. Where is there? So this would be something like 3,000 hertz. 3,000 hertz? No, 3,000 kilohertz. 3 megahertz. Yeah, maybe 3 megahertz. Yikes. And again, I don't know if that test was valid at all. How I'm doing this. I certainly suspect it's not valid. So I'm changing the ×1 ×10 on here. You can't see the scope, but along with the curve shrinking dramatically when I flip this, because this is less sensitive now, the resonant point goes way off into the... So this is definitely affecting the resonance of this. And this is a silly way to test it. Maybe I'd put some kind of resistors in here to isolate things. Maybe that would work better. I don't know, I'll have to go turn my coffee machine on at this point. After a lot of fiddling around, I finally did get what I'm after. So the sweep is now going, let's see, on the left it's starting at 100 kilohertz, and on the right it's ending at 536. That's okay. So 455 is inside that. There's the sweep. So that's roughly 455 right there. That's exactly what I've been looking for. That kind of response. How did I get it? So I grabbed the IF out of my collection that has SMD written on the side. Silver mica disease. That's me writing that. That's true. This thing does suffer from that. But what it's done, what's going on the scope now? It's tricky to get the good connections here. You might notice too, I have two scope leads coming here. One of them is coming from the signal generator. This one, I'm using scope lead on the signal generator because it has the switch here, which we can fiddle with. In fact, watch what happens on the... You see where it is, and then I'll flip that switch. You see it move to the right, and there's another funny shape here. Get a little closer to it. So yeah, hooking up these instruments definitely does affect the test. And is this the true resonant point? If it were in a radio circuit, probably not, because it's connected weirdly right now. But that certainly is what I'm looking for. Why have I not been able to find it on any of these other transformers? I don't know. It's really been driving me nuts here this morning. So I have another one here that's worth... Well, let's try this. Here's the one that's out of the radio. Appears to have a slug missing. For the life of me, I don't remember how that could have happened. But it is what it is. Let's hook it up here. Just see what happens. I very much believe in hook it up and see what happens type approach to things. Green dots here. I think the green dot is marking an output, the output side, but I'm not sure. So we are, yep, we're connected to this top coil, in fact. Now put the scope on. Something to grab there. I don't know. Grab this. Okay. Here we are. So now this is out of the radio. Look at that. Now it's hard for you to see. Let me turn the brightness up just a bit. So there we are. This is very resonant, right in the right zone here. can't know exactly what frequency that is, but wow, it's going to be really close to 455. Okay, I'll do a little bit more of a calibrated approach here. So we'll start this at, so we'll start the sweep at, say, 400. Well, how about 415? How about that? 415, does that make sense? 415, and we're going to end it at, let's say, 515. Why don't we do that? 515, so we would reduce this to 515. Okay, sweep away. What happened? There's no resonance. Did my thing stop here? How did that happen? We had this lovely resonant thing. What did I do here? I did something stupid. I'm on the 1 meg main scale. Yep, 1 meg. Start frequency at 400. Well, let's take it down. Go down. 300. 300 kilohertz, and the stop frequency, we'll leave it like that. Sweet. Oh my gosh, the resonance is showing it way down low. What has changed from what I did before? I was quite convinced it was running right around 455. This is suggesting it's way low. There is a slug missing, or I think there's a slug missing. Ay. I was pretty excited there for a minute, because I thought, wow, this thing is pretty close right on. Just stick it back in the radio. How far wrong can we be? But now, things have changed, Jim. So this is the increasing and decreasing the input to the circuit, and the frequency is not shifting. And then this is increasing and decreasing the sensitivity of the scope. Oh, see it move? So this is still affecting its resonance, the scope connection to my oscilloscope. What am I doing here? So let me move this like this. I'm just squeezing the coil a bit. One coil does nothing. The other coil changes the frequency and reduces the resonance, so it's ruining the cue of the other coil is doing nothing at all. How come you're doing nothing at all? Wouldn't you expect that to have an effect? Oh, we haven't seen much of you lately. Wait, don't go right through the work spot here. You coming to see what's going on? Trying to shove a piece of metal down inside this coil. Okay, so I can see something happening. Okay. What do we got here? If I could find if I could reassure myself that the metal slug that's in here is the slug that should be in there. Maybe that's all that should be in there. At some point, I got a hold of this. This is on my bench. This is a carbon slug. I don't know where did I get that from. I don't know, but it doesn't fit in here. It's too small. It just falls in the tube. Yeah, okay. Don't know where to go with this. So, hey, coffee must be ready by now. Okay, been out of my shop for about a half an hour doing other stuff, and I've just kind of walked back in. I guess I left everything operating, and I've got another camera I've set up in the meantime. Just to look at this. So this is the display on my scope with a sweep going through. Now the frequency where you see the peak is way low. This is going from 100 kilohertz to 500 kilohertz, so 455 should be over here somewhere, not in the middle like this. What I'm going to do is I'm going to fiddle around. This is, by the way, this is the transformer that came out of the radio initially. In fact, of all the things I've done, this is the best. This is the best one. I want to move the slug around. There's a large aluminum slug. I'm putting in a screwdriver into the... I'm going to rearrange this so you can watch what I'm doing here. Let me fix this up. Okay, so you get a good look at the scope now. You can watch me fiddle around here, and maybe I'll drop this down a little bit here. Okay. Screwdriver stuck inside the slug. It looks like the aluminum slug or metal slug down inside this coil. What happened to the carbon slug that was in here? I don't remember. The last thing I remember is discovering the metal and then saying, was the other one metal too? And then pulling out the screwdriver and looking at the tip of it and seeing there's carbon on it. There's carbon on it right there. But there's no carbon slug in there. And the two slugs banged together? Is it one, two slugs jammed? Am I just totally out of my tree here? It's amazing how I can move this around and the screen stays, display stays so steady. Famous last words. Okay, so I'm trying to move the slug. There we go. It's not working. My finger's touching the leads here. Noticed before the slug appeared to be cammed out. You know, when you put a slotted screwdriver into a screw and then the screw doesn't move and the screwdriver pops out, you end up messing up the slot in the screw head, and eventually it just turns into a ramp, and there's just no hope to try to screwdriver it out. It feels like that's happened here. I feel a little grip in one direction and nothing in the other. That's really bad. Holding on to something here. Oh my gosh. So you can take a screwdriver too, and you picture this tube. That's the tube, and down in there is the slug. You put the screwdriver in trying to aim for the slot. We end up in the side of the slug. Now you can't tell necessarily that that's what's happened. So now you're in there and you start turning it, you know, on the flat part of the screwdriver will start destroying the slug. Now this, I think, is a metal slug, so it can't be destroyed. Is it? Is it a metal slug? Let me scrape it a bit. I don't know what to say. This, you know, if you take a metal screwdriver and put it into one of these carbon or ferrite slugs, because the pressure will be just on the tiny sharp corners here, two corners as you twist, and then all that pressure on this little corner, and it's also in a it's not a compression force, it's a tension force. It's going to split the slug. Is that what happened? Did I split the other slug and it fell out and it's gone and goodness knows where it is? What am I doing here? I am really getting nowhere at all. Let me try a different kind of screwdriver here. Just see. Wow, that's got a really fine metal tip. I want a plastic tip here. The slot is quite wide. Well, this isn't going to go in there. Ooh, we'll go in there. It will. I don't think it's going to descend into the slot. It's too wide. Okay, it's a flimsy guy. Okay, it's in the slot. Camming out. Of course, you know what's happening here is that this is just twisting a bit, and then it's making its own ramp, popping out. I'm not getting anywhere. This is the reason I removed that in the first place. How can I get more aggressive with it? Let me get some more tools of the trade out here. Here's another one. This might be a good one here. Gonna fit. Okay, I'm watching the oscilloscope now. Am I moving anything here? I don't think I'm doing anything. And I don't think this descended into the slot. Yeah, this I can feel it's just going over the top. It's not descending into the slot at all. You son of a gun. So here's a metal end with a fairly wide. Let's try it. It'll certainly go in the slot. Oh, look what happened on the scope. What happened there? Whoa, wait a minute. Got fingers on stuff. Yeah, fingers on stuff. Ooh. That's more than that going on. Who's acting up here? Okay, it's moving. It's going over there. This might be 455. What are the chances that there's one single slug in this and that's all it takes? For some reason, some design I'm not aware of. Because it's right around 455 now, I'm pretty sure. Let me fix the sweep now. I'll focus the sweep in on 455 here. Okay, so what I'll do is I'm going to set the start frequency. We'll set it at 455 in the middle. It's a weird number. Let's put 450 in the middle. That's easy. That's 400 and 500 on either side. So we'll do 400. You're watching these numbers here. 400. No. This way. Okay, we do 400 pretty accurately. Okay, 400, and then the stop frequency will make it. If I make it 510, that puts 455 right in the middle, doesn't it? So we'll make it 510. It's almost there now. 512. 510. Yeah, I think that puts 455 dead center. Okay, sweep. Sweep. Where are you? So there we see where the resonance is. We expect the 455 to be right here. So I gotta move that slug further. I'm a little shocked that this is working. What did I use to do it? The metal? Okay. Maybe the metal itself was throwing it off. Not much. Okay, let's keep cranking. Get a grip on it. Come on, man. Somebody's not playing well here. Can I hold the plastic tube? Don't touch any of this. There we are. Okay. Adjust, adjust, adjust. right to the middle. I've tuned this to 455, I think. Have I just been totally wrong about this thing the whole time? So to prove this is 455, and I imagine it's very, very close, I can run another frequency into this, and we'll see. Now, is there another way to do this? Because I've got so much equipment hooked up, I'm just getting a false notion that it's working at 455. I put it in the radio and it's nowhere near 455. Well, this shows it's possible to get there under this arrangement. It got very, very small, but still right at that spot. This is the, I'm changing the input impedance by flipping the switch on my scope lead here, but this is not a scope lead. Frequency not changing. But the other one, I'm sure if I do this one, I think the frequency shot way, way, way up here. I'm not sure of that. Well, no doubt that has to come out. The one that's in the radio is never going to work. It's got to come out. And this one, I might as well put it back in and continue experimenting with this one. And because it sure seems to be resonating properly. Put this on the low setting, so the low impedance is presented to the coil here through this. You get that resonance, but when I put the impedance up higher, it just disappears entirely, which makes me think I've probably got a false impression on this. One thing I can put a big resistor in here. Put a resistor between here of some substantial size. Let me grab the big one. Oh, not a big one here. What would be a big one? Here's one with the green. Well, hello, Bert. What's going on? You can't get up here. There's just so much junk in the way. You can't jump up on my bench. Come here. Okay. Get a little bit of... A few of you have seen enough of my cats, but here he is again. What are you doing there? Okay. Yes. Go away now. Yeah, I'm going to actually close the door on you, Bert. Sorry, buddy. You just got the boot. Big resistor. Something with a green thing. There's a nice one. So this would be a brown, black, green. This is a 1 mega ohm resistor. Perfect. Let's try that. So what I want to do is just connect it here, and then connect it there, and see what happens on the scope. And put this on that's on the ×1 right now. And on the scope we see nothing. Really? What happened? Maybe we see nothing because there's nothing there. Oh no. Well, I'll put in a big resistor and okay, let's try 100K. It's 100K. So I'm assuming these resistors are good. Nothing. A little surprised to see nothing. Really? Can we go down even lower? Here's a 10K. Nothing. Oh, that's my fingers. Okay, a little surprised at that. I thought sticking a resistor in there really wouldn't have much impact on the screen, but especially a small one. Okay, maybe those resistors are no good. I don't know. Well, it looks to me like the only option I have going forward is to put this back in the radio and fiddle with it in the radio. Mysterious missing slug. Carbon pieces on my screwdriver, but no carbon slug, or no, maybe it's not carbon, it's another material, but do I think that's metal and it's really not? Didn't I like screw it right out and look at it and go, hey man, that's metal. I don't know if I said hey man, I don't know if I said that part. Screwing it right out, or I'm screwing it right up. One of the could be either way. Little bits of carbon, as if this is not coming out. I need to push it. This side seems to be all cammed up, if you know what I mean by that. Careful, Jim. Maybe there's only so much turning left in this thing. And I'm turning it out just to take a look at it. Oh, that's really ugly. Have a look. Have a look. If you can see in here or not, I don't know. So that looks like a carbon slug that's been worked to death. Well, that's what it looks like. It's right. It's in the coil a little bit, so it's about the width of the coil there, about the size of the coil. And the one below, there is none below. So, all these have been the same the whole time I've been doing this work. 2 slugs, 2 coils. I've never seen a 1 slug transformer. You know what? This would be in the, if it is 1 slug, it would be indicated, I think, in the instructions. And the opposite would be true too. So, let's go take a look at the instructions here. Okay, we're looking for alignment and hang on here. Okay. Alignment instructions. Here we are. So there you are, right there. It's showing that there are 2 different adjustments for each IF transformer. A and B being top and bottom, something like that's going on. This isn't making a lot of sense to me at all. Okay, that means probably coffee is what I really should be doing. Well, I've run out of time here today, so I got to end it here. So again, just pretty clear. I got to get rid of the IF transformer I installed. That'll never work in this radio. And at this point, my only option is to put the original one back in and somehow get it working well enough to pass a signal through the radio. Missing slug, I don't know. So that's it for today, and I may not do another video for almost a week. Who knows? We'll see. So thanks a lot for watching to this point, and this is taking a long time, but I'm very intent on getting this radio working somehow, some way, someday. See ya.